The final dynamic processor that we're going to examine this week is the limiter. Now, a limiter is an extreme downward compressor. So it's a downward compressor with the ratio set very high. Above 10:1, a ratio we tend to consider is a limiter. But the role of the limiter has been kind of changing in contemporary music. The original role of a limiter was to stop peaks, was to make it so the signal never goes above a certain level. And in that, it was very useful. If you think of a live stage situation, think if you have a vocalist, right? And they tend to just drop the mic or swing it around or scream into it. And you don't want to hurt your audience. So you put a limiter on that microphone so that if they do drop it, if they do scream into it, the level never gets above that specific set point, that threshold. And you set that so that the loud sound doesn't hurt your speakers and doesn't hurt your audience. So it had a kind of protective role. And in that, you want to make sure the sound never gets above a specific level. So it would be a compressor with a very fast attack and even a little look ahead, and also a very high ratio. So you would think of it as, you might even hear the term a brick wall limiter, meaning it's never going to get above a specific level. Now, in that instance, those limiters tend not to sound very good. They have more of a protective role. And in that, they're very good at, but they don't really sound great as you get to them. As we've kind of moved on through technology and get more digital signal processing, the role of a limiter has kind of evolved to be a loudness maximizer. And some plugins are actually calling it that now. And so an original limiter as a protective device would just come on once in a while, right? Hopefully not even at all. But when it did, it would just turn on and turn off very quickly, trying to be transparent and just protecting the audience. In the contemporary limiters, which are also known as loudness maximizers, they're kind of running more often. And their goal is to make things sound as loud as possible, but not increase the amplitude, right? Remember that distinction between loudness and amplitude? Amplitude is measurable, but loudness is the perception. So the idea with these contemporary loudness maximizers is to make it seem louder, but not actually increase the volume at all. So we're going to examine the kind of traditional role of a limiter and kind of also look at how a loudness maximizer functions in a contemporary mix.
We mentioned earlier that a limiter is an extreme compressor. It's a compressor with a very, very high ratio. And to function as a brick wall limiter, it also has to have a very fast attack or a low attack time. That way it will capture and stop all the transients, so nothing is allowed to get above that threshold. I have this compressor set up to be in one of these very fast attack and release limiting modes. And the reason I'm bringing this up now is I want to point out the issues involved in heavy limiting. Heavy limiting and compression is a common thing in contemporary mixes. We want to make things sound as loud and powerful as possible. But in doing so, you do introduce the chance of distortion. And we have to be aware that we always have this dynamic range, this issue between noise and distortion. We saw earlier that using compressors heavily and using a makeup gain increases the noise, and now we'll see that pushing compressors and limiters too hard introduces distortion. And it's always your job to stay between those two things, or when you go beyond them, to do it musically. So we'll start this example like we did the gate and compressor with a more abstract example. And I have a low sine wave tone that I'll play through this plugin. So we see with the sine wave that we have energy at a single frequency, and it's quite loud as it is. Now I'm going to start compressing this signal with a very fast attack and release compressor. Basically, I'm in limiting mode now. And I'll reduce my threshold. Let's watch what happens. We see that limiting this with a very, very fast attack and release has distorted the wave shape, and it's given us a series of upper harmonics. We have distorted the signal, and this looks very much like the clipping distortion we analyzed earlier this week. So we have to be very careful with limiters and compressors and even gates not to get in a situation where we're adding upper harmonics that we don't want. Now this can be used musically, but usually you set up a compressor to avoid this kind of situation. This is most commonly a problem with low frequency notes, like I have in this example here, because the attack and release time on my compressor are set so fast that the compressor is responding to every single oscillation of that low waveform, causing this distortion. So if we want to remove this, we have to start manipulating our attack and release times. But there's always trade-offs. Let's try it out. This time I'll start raising my release time. And we see that's changing the distortion. Because that compressor is not allowed to move as fast, we're reducing the amount of distortion. I'll raise up my attack time a bit. A little more release. And now we're to the point where I don't really have audible distortion. I don't see the distortion here, and I also don't hear it in my headphones. So now I'd be free to lower this threshold even further. I'm reducing the sound without introducing unwanted distortion. The trade-off is this. If I play a key now, if I play this note, we're going to see a little bit of that transience let through. Let me make it more obvious by increasing attack even more. So we see a little bit of that transient at the beginning of the note. The limiter's not moving fast enough to avoid that initial click. So that's the trade-off we're always working with limiters. We want very fast attack times and fast release times if possible, but when we do so, we introduce the chance of distortion. If we increase the attack time, we introduce the chance that something is going to get through the compressor or limiter. Let's look at how a limiter functions now. And we'll see it's going to be very similar to this, but I want to show you one difference. In a limiter, we have a threshold control that is directly associated with a makeup gain. So as I lower threshold, it automatically brings up the output gain. And we're going to hear that this is going to be very similar to what we did with the compressor. Let's try it out. I'll start lowering the threshold, but this time you see it's actually bringing up the output automatically. Watch, see that waveform get bigger? So with the limiter, as you lower the threshold, it actually increases output gain automatically. This is bringing up the level. Look what happens. Right when I cross that threshold, we get distortion, just like we did with the compressor. Now, we have a speed control on this limiter, might be called release on other limiters, but increasing that can reduce that amount of distortion, just like the release and attack controls in a compressor reduce the chance of distortion there. So we're finding these same controls between compressors and limiters. The only difference here is really how this threshold works. As I lower the threshold in a limiter, it also increases the output gain automatically. It's like having auto gain on one of your compressors. We're going to end this examination of dynamics processors by compressing a drum groove. And we're doing this because we have to train ourselves to hear compression before we can actually use it in a musical manner. I think in a week, and with these lessons that we've done, you should have a good foundation for how these devices work. It's going to take much longer to first be able to hear them and then be able to apply them musically. So, this is an experiment I would like you to run for yourself. You're going to load up some kind of drum groove played by a real drummer that has a little bit of room around it, and we're going to compress it heavily. And I want you to observe how the sound changes and how you can manipulate that drum groove with a compressor. It's a great way to start hearing the effect of compressor, start knowing what it sounds like, and start understanding how the different parameters in a compressor impact the final product. So let's hear the drum groove now. So this is the uncompressed drum groove. What I'd like you to do first is increase the ratio quite high, set your attack quickly in the millisecond range, and your release in the 100 millisecond range. Doesn't have to be precise. And then as it plays, start lowering threshold. When the level goes down, bring up the makeup gain a bit. And then start observing, what are you hearing differently? Can you describe the change that you're hearing in this? I'll go even further. So what I notice is now the hi-hat seems to be at a much more similar level to the kick and snare. It seems to even out the hits so they sound more consistent. I'm noticing more of the subtle snare hits that are in this groove. There were some very quiet, subtle snare hits. Those seem to have gotten louder as I did this. I'm noticing much more of the room tone. So it feels like I've added reverb to this in a way, and that all the room has gotten louder, and it also seems like the sustain of the cymbals is now longer. Let's hear it both on and off. Here's it off. And then with it on. And I'm adjusting the makeup gain so they end up about the same level. That last cymbal seems to last much longer. This sounds much drier. I feel like I'm losing the attack on the individual drums, like it's kind of muted in a way when the compressor's on. So this is the experiment I'd like you to try, is listening to a drum groove and compressing it heavily and being aware, kind of an analysis of what you're noticing. See what changes and then manipulate these things in a logical manner. So what happens if I start increasing attack in this situation? Oh, look. The transients come through more. I start noticing those individual transients punch through. We get like a heavily compressed sound, but we get these punchy transients. If I reduce that attack, those transients go down. If I increase release or decrease the release. Oh, the decreased release has a really So with that quick release, we hear that kind of room tone really punch in with each hit and kind of vanish. We get that pumping sound that we try to avoid. So a careful adjustment of release on a drum groove is going to have a major impact. So with release low, we really notice that noise. So that's how I would say you have to approach learning compression. It's actually experimenting with it. And the one thing I would say that could take it beyond this, kind of in your learning and learning to hear and utilize these devices, is perform your instrument while compressing it. Or even talk into the compressor. I find it's very interesting as you're performing your instrument, you're feeling how the compressor is responding to you. So as you play louder, the compressor pushes it down. As you play quieter, the compressor opens back up. And as you're performing into it, you're really going to get a sense of how that compressor, how that dynamic processor is related and interacting with your performance naturally. So those are the major dynamics processors. We have gates and limiters and compressors. We've looked at the extremes in this course here so that we can understand how these function. It's going to be up to you to take it to a more musical usage in the future, but the only way you're going to get there is if you know how they function and you know what the extreme sounds like, because then you'll be able to back that knowledge down into a musical range. I'd like you to go to your DAW and experiment with this. Try to open a drum groove and compress it. And then as you're listening to records from now on, try to recognize the sound of compression. It's quite obvious once you get used to hearing it.